let's find the vertex for this guy. So there are a few different ways of doing this. If it's in this form where your quadratic is ax plus ax squared plus bx plus c, where a, b, and c are just numbers. It doesn't have to be pluses, they can be minuses, but to find the vertex, the x-coordinate of the vertex is negative b over 2a. So in this case, a is 1, b is 6. A and b, the first number. The number in front of x squared is a, the number in front of x is 6. And you say negative 6 divided by 2 times 1. So 2 times 1 is 2. So negative 6 divided by 2 is negative 3. Now that is the x-coordinate of the vertex. So, by the way, the vertex is that lowest spot of the graph, right? Alright, so negative 3 is the x-coordinate. Now the y-coordinate, you can find that by plugging it back in to the function. Plug it back in right here. So let's plug that back in. Negative 3 squared plus 6 times negative 3 plus 5. So it would be 9 minus 18 plus 5. That'd be negative 9 plus 5, which would be negative 4. So negative 4 is the y-coordinate of the vertex. So we've got the vertex. All right, determine whether there's a maximum or minimum. If your a value is positive, then the vertex as a quadratic opens upward. If it's negative, it opens downward. So let's draw this out here. Here's the vertex. Back 3, down 4. And since my a value is positive, it goes up. It opens upward. So I know this much. Determine with the maximum minimum value and find that value. So this vertex is the very lowest spot, so it is a minimum value. And that value is, we'd say that's a minimum at negative 4 when x equals negative 3. There's a minimum value of negative 4 for that function. That's the output, right? Negative 4, the y value, when the x value is equal to negative 3. What's the range? Well, the range it would basically be how tall it is. Any parabola is going to have a domain of all the numbers, but the range is basically how tall it is. So it's going to start here at negative 4, and it is from negative 4 to infinity. So the range would be negative 4 to infinity. All right, so the next part says find the intervals on which the function is increasing and the intervals on which the function is decreasing. So you move left to right. So as I move left to, if I trace this, it is going down until I hit this spot right here. So this interval going this way is decreasing. And it's decreasing from negative infinity to, what's this value here? Negative 3. We use a parentheses for that. All right, and then if I trace it, if I keep on tracing it, it's increasing from here this way to the right. So it's increasing from 3 to infinity. There's my intervals of increasing and decreasing for number 22. Let's try it again. So I'm going to do this without trying to explain too awful much. Here we go. So now I'm just going to go through here, find the vertex. So number 23, a, we're going to do negative b over 2a. That's going to be the x-coordinate of the vertex. My a value is 2, my b value is 8. So negative 8 over 2 times 2. Negative 8 over 4, negative 2. That's the x-coordinate of the vertex. So now if I plug that back in and find f of negative 2, we have 2 times 2 squared, negative 2 squared, plus 8 times negative 2, minus 4. That would be 2 times 4, minus 16 minus 4, and that would be 8 minus 20, and that would be negative 12. So negative 12 is the y-coordinate of the vertex. This is the x-coordinate. Negative 12 is the y-coordinate. So if I draw that real quick, back 2, down 12, and since my a value is positive, it opens upward. Just a quick sketch. All right, part B. Where does it have a maximum or minimum? It has a minimum. It has a minimum value at negative 12, of negative 12. I should say of, when x equals negative 2. What's your range? That's part C, the range. Well, it's the y values start at negative 12 and go on up to positive infinity. They go forever, the y values do. So we're going to include negative 12 to infinity. We'll include negative 12. We'll do square bracket. And then where is it increasing or decreasing? Well, if I trace this, I'll be going down. Moving left to right, I trace this down. And what's that x value right there? That x value is at negative 2. So from negative infinity to negative 2, it's decreasing. That means, and then it's going to go up. So it's going to increase from negative 2 to infinity. It's going to increase as I go up. From the x value of negative 2, we're increasing. Cool. Number 23. Oh, we did that one. 24. My a value is negative 2. My b value is negative 12. Negative b over 2a tells me the x-coordinate of the vertex. That's a negative 12 over 2 times negative 2. So that'd be 12 over negative 4, which is negative 3. So my x-coordinate of the vertex is at negative 3. So if I plug that back in, I'd have negative 2 times 9 plus 36 plus 23. Be negative 18 plus 36 plus 23. That'd be 18 plus 23. Be 38, 41. Yep, 41. That's the y-coordinate of the vertex. So my vertex is at negative 3, 41. So if I go back 3 and then way down here is 41. There's a really horrible sketch. And it asks for the same things. So it has a minimum value of 40. Oh, shoot. It's not down 41, it's up 41. It really was a horrible sketch. Back 3 and up 41. Minimum, still has a minimum value of 41 at, wait a second. I just assumed it opened upward. Wait a second. Wait. I have to look at my a value. Remember that? I have to look at that a value. The a value is negative. Will you ever screw up that much before? Back 3, up 41. But the thing opens downward this time. The thing opens downward this time because it has a negative a value. Boy, I about screwed the pooch on that one. So it has a maximum value this time because it's on the very tip top. At x equals negative 3. Man. So, what's the other question here? What's the range? Well, it comes in from negative infinity and it tops out here on the y-axis at 41. So it comes in from negative infinity and it tops out at 41. And we include 41, so it's a square bracket. Where is it increasing and decreasing? Well, this time it's increasing. This time it's increasing from negative infinity to, what's that x value? Right there was negative 3. Parentheses. and then it would be decreasing from -3 to positive infinity. I hope that's the last one, because I screwed up big time on that one. Let's see. Is there any more here? What's number 25 say? Jeez. Another one. Work it out the same way. Piece of paper here. Come on. All right. 25. I'm going to make a note of this. My A value is -8. My B value is -8. And right here, I'm going to make a note of it now. It opens downward. Because it's a -A value. So now I won't screw up so bad. -b over 2a tells me the x-coordinate of the vertex. Notice how whenever I go through all these problems, I restate the same thing over and over again, and it seems like it helps me to remember what these formulas do. So it's just another study tip, I guess. Negative from the formula, and then a -8, 2 times a -8. That'd be a positive 8 over 2 times 8, which is -16. 8 over -16 is a -1/2. So my x-coordinate is -1/2. Now to get the y-coordinate, remember what we do? We have to plug that back in. So when I plug that back in, when we do, we're going to get -8 times 1/4 plus 4 plus 9. 1/4 of 8 would be 2, so it would be -2 plus 4 plus 9, which would be 2 plus 9, which is 11. So my vertex is at -1/2, comma 11. Cool. Where is it? Is it a minimum or maximum? So if I graph this real quick, you go back a half, up 11, it opens downward. So this is going to be a max value of 11 when x equals -1/2. And then what's the range? It tops out at 11. So the range is going to be -infinity to 11. Square bracket on the 11. Increasing and decreasing. It's increasing till it gets to here, which is -1/2. So from -infinity to -1/2, the graph is increasing. And that means it's decreasing from -1/2 to a positive infinity. Just because it's a parabola, it's never going to curve back up. All right, so there are 4 questions about finding the vertex, max and min, range, and increasing and decreasing intervals for quadratic functions.